hi guys. So we're going to continue with part 2 of subtopic 6.2. So our learning objectives will be to use the equation Kp equals to Kc RT delta N to solve equilibrium problems, and we're going to calculate Kp, Kc or other quantities. So the quantities Kp, Kc and other quantities at equilibrium. So this one, there's two ways. We can either use the formula that we already have, or you have to use I stable. So what is I stable? We will see later how it looks like. Okay? So first we're going to see the relationship between Kc and Kp. So Kc and Kp are related by this equation. Okay? Kp equals to Kc RT delta N. So how do we relate Kc and Kp? It is by using the ideal gas equation PV equals to nRT. So how can we do that? First, we're going to have to assume that our gases are behaving ideally. So for this equation, for this reaction, if we write the expression for Kc, we get this, and Kp, we get this. How can we derive Kc in here, in this equation? We will have to first find the partial pressure of each of the gases. Okay, so from the partial pressure, you find the partial pressure using PV equals nRT, and then you will get a relationship between partial pressure and concentration. So you get this, alright? So partial pressure and concentration. So from there, you are going to substitute your partial pressure into your Kp expression. Okay, your Kp expression, you're going to put in these partial pressures. So when you substitute in your partial pressure, you will get back your Kc. So you get your Kc balik, your Kc right here. Betul tak? You are taking out your RT, right? Your RT, you are expanding it out. So then you will get your Kc. Kc, RT, and here you have your delta N. So your delta N here, you get it because apa? Indices kan panggil benda ni. So your C times dengan C yang bracket ni times dengan this one, you will get plus, lepas tu minus because of this divide your reactants pula. So it's actually the number of moles for your product minus with the number of moles of your reactant. Alright, so this is your delta N. So you can use Kp equals to Kc RT delta N when you either have your Kp or Kc and your number of moles. Okay, so for example, like this question here, it told you, so the equilibrium constant for Kp for the reaction is 1.8 times 10 minus 5, right? At 350 degrees Celsius. So what is the Kc for this reaction? So if you use the formula Kp equals to Kc RT delta N, right? You will just have to find the delta N. Okay? So, and the temperature, you have to change it into Kelvin. So change this into Kelvin. And then you have to find your delta N. So what is your delta N? So your delta N will be the number of moles of product, which is here 4 plus 6 minus 4 plus 7. Berapa tu? So it's 10 minus 11. That will be minus 1. Okay? So just masukkan your value and you will get the Kc, right? So you're going to rearrange that formula. Kc equals to Kp over RT delta N. Okay, so just sub in your values and you will get this answer. Next, we're going to see how to determine the Kc, Kp, and quantities of species at equilibrium. Okay, so for a reversible reaction, let's say this is your equation. If you are given this kind of sentence, you have to be alert that you have to use the ice table. Okay, so when you get this kind of sentence, if A moles of reactant A and B moles of reactant B was allowed to achieve equilibrium in V liter container. So this kind of sentence, this is not information at equilibrium, not equilibrium. Okay, be alert that it could be ni moles kan. Ni moles kan. It can be pressure, it can be concentration, it can be mass. Okay? It can be any quantities of your substance. And then the ayat, the sentence was allowed to achieve equilibrium. Maksudnya it hasn't achieved equilibrium. But the sentence can also be was introduced to. Maksudnya initially lah. Initially ke baru je. Injected into into a volume of container. Be alert of those sentences because that isn't your quantity in at equilibrium. Okay, maksudnya dia initial quantity. We assume it is the initial quantity. Alright, therefore you will have to use ice table. So what is ice table? Ice table is actually I stands for initial, C stands for change, E stands for equilibrium. So let's say macam selalunya we will use mole. So mole initial. So change I will write it as delta N. Ini equilibrium I will write as N equilibrium. So your X is the amount of mole of reactant that dissociates. So that's your change. Ini it will be X. It is in the unit, bukan unit lah, macam use letter X to lambangkan dissociation. Okay, dissociation. Okay, so yeah, so to find your mole at equilibrium, you will have to use initial mole minus with delta N awak. Okay, so let's see how can we use our ice table. From this question, it says that the natural gas methane CH4 reacts with steam to produce hydrogen gas. So here is your equation, and then it says that in an experiment 3 moles of methane, 0.6 mole of steam were introduced into. So this is your quantity. Okay, in an experiment into your volume of container. At equilibrium, so at equilibrium, 0.5 mole of carbon monoxide is present in the mixture. So that means the first part of your information is not at equilibrium. So this will be your initial. Okay, initial conditions, initial information for your initial condition. Okay, so you want to calculate the number of moles of your CH4, H2O and H2 in the equilibrium mixture. So that means you need the N equilibrium. Okay, for your gases. What you have here is N initial. Okay. Alright, so but you don't know the number of moles at equilibrium. So we are going to use ice table to find out the number of moles at equilibrium. Okay, now I'm going to show you how to use the ice table. Okay, so first you're going to write down your reversible reaction equation. So you have CH4 gas plus H2O gas, and then equilibrium CO plus 3H2 gas. Okay, and then I'm going to bring down the, boleh je kalau tak pun, tapi tak apalah, bring down, you know, to be proper. CO and 3H2. So I stable, we're going to have our N initial, that's the format, delta N, your change, your N equilibrium, that's your mole at equilibrium, and then you're going to write down concentration at equilibrium, because you will usually always need to use the concentration at equilibrium to find Kc ke whatever. Okay, so the initial number of mole, so from your information you know that you have 3.00 mole of methane. So 3.00 mole of methane, 0.60 mole of water, steam, carbon monoxide at initially. Okay, initial, note. Initially, you only have your reactants. You haven't formed any products. So this one, this part will be 0. Okay. Okay. You don't have your carbon monoxide. You don't have your hydrogen gas yet. Alright. Okay, boleh? So, now, delta N, you will look at the stoichiometry of your stoichiometric coefficient of your substances. So, methane only has 1 mole, therefore, your changes will be, what will happen to your reactant? You will consume your reactant, right? So, your reactant will deplete. Maksudnya berkurangan. So, you will write minus X. Water ada 1 mole juga, so minus X. 1X. Right. So, your product will increase, right? The mole of your product will increase. Therefore, you are going to write plus X. And then, your hydrogen, the dissociation will be plus 3X. 3 because you have 3 moles of water. 3 moles of hydrogen. So, plus 3X, okay? Alright. So, now you're going to find out the mole for at equilibrium. You will just bring down, you will plus those two together, okay? Okay. So, ini jadi X, ini jadi 3X. Okay? So, maksudnya, at equilibrium, your number of mole will be 3 minus X for methane, 0.6 minus X for water, X for carbon monoxide, and 3X for hydrogen. Right? So, to find your concentration at equilibrium, you're going to use apa? Macam mana? N equilibrium over volume, betul? So, you're just going to divide with volume. So, what is your volume? Your volume is 1 dm cube. So, that's 1 liter. Then 0.6 minus X over 1 liter. Then X over 1 liter. And then 3X over 1 liter. Okay. So, once you have this I-stable, so you have all this information, right? So, you're going to use this information in order to find the number of moles of your methane, water, and hydrogen. Okay. But you only have this. Okay. What are you going to do? You are going to find out X. Okay. If you read your question balik, it says that at equilibrium, 0.5 mole of carbon monoxide is present. That means, so compare the information that you have at equilibrium. At equilibrium, you have 0.5 mole of carbon monoxide, right? So that means your carbon monoxide, your X is 0.50 mole. Betul? Kan? Okay. So that means you already find your X. Okay. So now you can find your concentration at equilibrium, right? So you're just going to find concentration for apa ni? CH4 will be 3 minus X. X awak berapa? 0.5 over 1. So kira lah berapa? 2.5 molar. Betul? So you can find for water. Water, you will get 0.1 molar. And then for... sorry, molar pula anakku. Apa saya ni? Oh, bukan nak cari concentration kan? Tak apalah, lang-lang tu dah cari concentration. Okay. Concentration of hydrogen. 3 times 0.5. Okay, this is concentration. Your question A, it asks for a number of moles, okay, at equilibrium. For CH4, H2O and H2. So carilah, boleh kan? You're basically doing the same thing. You just substitute in X yang awak dah jumpa tu. Right, and then B, it asks for your KC expression. So KC expression macam mana? KC expression will be H2 3 then CO over CH4 and then H2O. Right? So, just masukkan your concentrations that you found and then you will get the answer, which is 6.75. Remember that it has no units. Alright? Okay, I'm just going to give you some hints for this question. I'm not going to do it. So for this question, so a pressure of 0.464 atm carbon dioxide is introduced into a closed vessel that contains graphite at 1000 Kelvin. So the reaction occurs as follows. Okay. When the system reach equilibrium, okay, maksudnya this one, the pressure 0.464 atm ni is not the pressure at equilibrium for carbon dioxide. That means that's the pressure initial for CO2. Okay. So, when the system reached equilibrium, okay, ni dah equilibrium, the pressure in the vessel was found to be 0.746. So, this one is your total pressure at equilibrium. Okay. So, calculate the partial pressure of each species at equilibrium. So, you're going to find the pressure equilibrium of CO2 and CO. So, carbon ni, dia solid. So, you're not going to include it in your equilibrium constant. So, just ignore it. Alright? So, to find the partial pressure of each species at equilibrium, you are going to use what formula? Since you have the total pressure, right? This one here, total pressure at equilibrium. After drawing the ice table, after putting information in your ice table, you can use the pressure of at equilibrium for carbon dioxide and carbon monoxide to find the value of X. So after you find X, you can find the partial pressure of each of the gases. Alright? And then after you find that, you can find Kp. Okay? So that's the answer. That's the answer. So you can do it by yourself and check it. For this question, nitrogen oxide decomposes according to the following reaction. So you are given Kp 83.3 and this is your reaction. And you have, if 4 grams of NO gas is placed in a vat 2.0 liter vessel and allowed to come to equilibrium. Maksudnya, this information, this mass of NO gas is your initial mass. So mass initial of NO. Okay, not at equilibrium. Okay. So dia suruh cari the equilibrium concentrations of NO, N2 and O2. So maksudnya you have to find equilibrium concentration. So you have to draw the ice table. Right. Okay. After finding the concentration, the question asks you to find the equilibrium partial pressure for each gas. To find the equilibrium partial pressure for each gas, what can you do? Okay, if you've done it up until your ice table, right, and then you found X already, so meaning you can find the number of mole of your gases. So after finding the number of mole of your gases, mole at equilibrium of your gases, you can use PV equals to nRT to find the partial pressure of each gas. So maksudnya you're going to rearrange your formula into P. So ini yang equilibrium ya. So contohnya for N2, your formula will be like this. So volume. So you have your mole at equilibrium of N2, then R and T. Okay? So and then you can find the partial pressure for each gas. Boleh? And then the third question, mass of oxygen tu awak boleh cari lah juga. Okay? Okay, so this question, I want to do it with you. Okay, so it says that bromine gas is allowed to reach equilibrium according to the equation Br2 gas forms 2Br gas with Kc 1.1 times 10 minus 3 at 1280 degrees Celsius. If the initial concentration of Br2 and Br are 0.063 molar and 0.012 molar, calculate the concentrations of these species at equilibrium. Bagaimanakah itu? So you have the concentration, initial concentration of Br2 and Br. So that means initial concentration. Initial. So instead of mole ke mass ke, sekarang you have initial concentration. Alright, of Br2. Br2 0.063 molar and Br you have 0.012 molar. Okay, and then it asks to calculate the concentration of these species at equilibrium. Okay. So, for this question, you are given Kc juga. Okay, Kc. Okay, so what are we going to do first? Since we need to find the concentration of the species at equilibrium, then we're going to use ice table. Alright? Okay. Okay, first things first, you're going to write down your chemical equation. Okay. And then you're going to write down the concentration initial. Apa yang initial? And then you're going to write down the delta concentration. Okay, the change in your concentration, your dissociation. And then you're going to write down the equilibrium concentration. Okay? Your initial concentration for Br2 is 0.063 molar. Ni Br 0.012 molar. So, the change, tengok awak punya mole berapa dekat awak punya equation tu. So, for this question, Ada lagi satu step yang awak kena buat. You have to find the QC. So, to find the QC, it will be BR dua over BR2. Because kalau dia bagi tahu KC and dia bagi tahu initial concentrations, then you should check the QC to see whether your reaction is going forward, is starting from bromine to BR atau BR2. Okay, so find that first. So you have 0.012 and you have 0.063. So you will get 2.29 times 10 minus 3. Yang ni awak akan learn later, tapi saya dah termasukkan dalam ni kan. So saya ajar je lah terus. So this is your reaction quotient. Okay, reaction quotient at the initial condition, at initial time. Initially your reaction punya constant at that time is 2.29 times 10 minus 3, while your Kc is 1.1 times 10 minus 3. So right now what you can conclude is your Qc ke Kc lagi besar. So right now your Qc is bigger than Kc, right? So ini 2.29, ini 1.1 je. So if this is the case, you will see later that means, so when you have more product than reactant, that means you have more 2Br than Br2. That means your reaction will shift to the left. Okay, so if it shifts to the left, that means that to achieve equilibrium, your reaction will shift to the left to minimize the amount of product. Okay, sebab you have more product than reactant. So you want to achieve equilibrium, kena balance. Okay, alright. So that means right now your reaction is going to the left. Okay, so that means for your delta, this will be plus X sebab itu dah awak punya product. Okay, ini awak punya minus 2X reactant because it is going to be reversible lah. Okay, right. So continue. 0.063 plus X. Ini 0.012 minus 2X. Alright. Okay. So now that we have the concentration at equilibrium, we are going to use that. And we're going to use Kc here to compare, to find X, okay? So Kc equals to Br okay. So masukkan berapa? 0.012 minus 2X square over Br2 0.063 plus X. Okay. Sama dengan apa? 1.1 times 10 minus 3 kan? Okay. So nanti awak kena buat quadratic equation. Okay, when you do quadratic equation, and then you will get two values of X. So in this case, you will get 1.78 times 10 minus 3 dengan 1.046 times 10 minus 2. Okay, so you're going to only use one of the values of X. So which one are you going to use? So in this case, you get both positive values of X. What you're going to do is, you're going to choose the smaller value. Okay, so in this case you're going to use this one. This is smaller kan? So use this value. If you get both positive X values, choose smaller value. Okay. If you get one positive and one negative, choose positive value. Okay. Alright. Why is it that way? Because you cannot have a negative value. Alright. And why you choose the smaller value bila you have positive values of x? Because your gases are weak species, so the Kc should be small. Alright. So from there, when you get x, you can find the concentration of the species at equilibrium. Alright, that's all for the example. So we're going to summarize. So what we learned just now, we learned how to relate Kp to Kc with the ideal gas equation. So you get this equation. So remember how to derive it in case there's that question in the exam. And then you learn how to calculate Kc, Kp and other quantities like mole, concentration, partial pressure at equilibrium, right? So when you don't have enough information, you are going to draw the ice table in order to find x and solve your problem. Otherwise, you're just going to use your formula like normal. Okay, if you're given the information for all information at equilibrium. So you use ice table and you're not given quantities, okay, quantities at equilibrium. And you need to find information for quantities at equilibrium. Okay, macam tu